All right, hello everyone. We are working on the final exam study guide. Yay, almost done. I'll be doing just task 2, the calculator portion. So make sure you have a calculator available as you go through this. The other portion is the non-calculator, so when you work on that section, try not to use the calculator since you won't be able to on your final exam tomorrow. Okay, so we'll just go ahead and jump right in. All right, so first question. Frank runs at a rate of 8 feet per second. Create a function f where f of x gives the number of feet he runs given the number of seconds x. So number 12 is an easy, just writing a function. So it asks us to use f of x. And we want to know how many feet he runs after x seconds. So if he's running 8 feet per second, so remember when you have that word per, that normally indicates that this number is going to go with a variable. So it's 8 feet per second. So that would be 8 times the number of seconds, which is x. So if he runs for 10 seconds, he should travel 80 feet because that would be 8 times 10. If he runs for 30 seconds, it should be 240 feet because that would be 8 times 30. If he runs for 2 seconds, it would be 16. It would be 8 times 2. So you're plugging in your seconds in for x. F of x would be the feet. Okay. All right, 13. Ian received a piggy bank for Christmas with $50 in it. Once a month, his parents give him $15 to add to his bank. The table shows the amount of money in his piggy bank every month. Okay, so part A, on the final tomorrow, since it's on the computer, you will have to there'll be some blanks and you'll have to pick your number. So I tried to simulate that as best as possible. We're just circling here. So how did the money, f of m, in Ian's account change each month? Circle the appropriate word or words in the underlined portion to correctly complete the sentence. So, if I look at his account, each month, how much is his account changing by? So, it is increasing by $15. Okay, so each month, the amount in Ian's bank increased. Now, I can tell that because this number is getting larger, it's increasing, it's getting bigger, and it increases by $15 each month. And since it's the same thing each month, that is a constant rate of change. If it increased by 5 and then 10 and then 15 and then 20, then that would be a varying rate of change, but it's the same number each time, so it's constant. All right, part B, create a function f where f of m models the amount of money in Ian's piggy bank given the number of months, m, after the initial deposit. So we're going to set this up just like we did on number 12. And since he's increasing by $15 per month, or each month, 15 is going to go by m. So every month I increase by $15, or I change by $15, or I add $15. So that's why that's with the m. That is my slope. That's how much I'm increasing by each month. But prior to getting $15 a month, at Christmas I got $50. That's a one-time payment. So at month 0, I had an initial deposit of $50. So that's where this came from. And that's not something that changes. That's just a one-time thing. So it's just going to be plus 50 at the end. And that's it. Okay, 14. D has to fertilize her plants every week. The amount of water must be no more than 5 times the amount of liquid fertilizer added. So let Z represent the number of ounces of water, and let F be the amount of liquid fertilizer. And write an inequality to show the relationship between the water and the liquid fertilizer. Okay. So what we know is that however much water we have, it can be no more than 5 times the amount of fertilizer. Okay, so if Z is the water The water can be no more than, so that means that this has to be less than or equal to whatever I'm talking about. So we'll have the amount of water is no more than or less than or equal to 5 times the amount of liquid fertilizer. So I would have to do 5 times the amount of fertilizer. So this is exactly what we have here. The amount of water, Z, must be no more than, less than or equal to, 5 times the amount of liquid fertilizer, F. Okay, and so we're done with part A. Part B, which of the following combinations allow D to treat her plants with the water and fertilizer while limiting the water to no more than 5 times the amount of fertilizer? And then it says select all that apply. So this would be like a bunch of check boxes. You would have to check each and every answer. Since if it were just a multiple choice and just select one, I would still encourage you to check every answer and just make sure you've selected the best one. But here, we definitely need to check each answer and make sure which ones are appropriate and which ones are not. Because there's a possibility that they all might be true statements, or there's a possibility that none of them are true statements. Actually, I don't know that I've ever seen that, but just, you know, you never know. Okay, so all we're going to do is we are going to plug in the amount of fertilizer for F, and then the amount of water for Z, and we're just going to make sure it's a true statement. So we have 30 ounces of water. Is that less than or equal to 5 times the amount of fertilizer, 10? Is 30 less than or equal to 50? Okay, so is 30 less than or equal to 50? And it is, so A is a true statement. And we're going to do the same thing for all 5 of these. So we have 75 less than or equal to 5 times 15. Is 75 less than or equal to 75? And that, since it is equal to, if this were just less than, this would not be true. But because it has the equal to bar, it is a true statement. C, is 120 less than or equal to 5 times 20? So is 120 less than or equal to 100? No, it's not. So C is not a true statement. And we're just going to follow that same pattern. 150 less than or equal to 5 times 50? So is 150 equal to 5 times, no, I'm sorry, equals to 250. And it is, so this is a true statement. And the last one is 300 less than or equal to 5 times 60. So is 300 less than or equal to 300, and it's true. So for part B, the only solution, or the only ordered pair, or the only combination that is not true is C. A, B, D, and E are all true answers. So there we go. Okay. Oh, not this page. All right, so that was number 14. Let's do 15. Okay, I don't know if anybody else is weird about this, but like I can't write on just one piece of paper. I have to have a paper on bottom. I think that's weird, but it's me. I don't know. I don't think I'm the only person that does that. Okay. All right. So 15. I actually really have always liked this question, but I'm a nerd. I don't know. 15, part A. The function f, where f of y equals 300y plus 1,000, represents the number of cows added to a growing dairy farm since opening in 2010, with y being the number of years since. How many cows did the dairy farm have in 2016? Show your work. Okay. So, we have f of y equals 300y plus 1,000. So this is the number of cows since 2010. And we want to know how many they have in 2016. So I need to know the number of years that have passed. Which should be easy math, but you know. So this, oops, I'm crazy today, should just be 6. So 6 years have passed. So I'm gonna use this 6 is my number of years that have passed, so that would be my y. So I'm gonna do f of 6 equals 300 times 6 plus 1,000. So 300 times 6 would be 1,800 plus 1,000. F of 6 should equal 2,800. Okay. All right, part B should be worked just the same, or very similarly. I think, actually, this is just interpreting it. This one doesn't even work. The function P, where P of X represents the percent of states in the country with dairy farms X years after. Oh. Okay, sorry, it didn't read well. Okay, we're looking at the function P, where P of X represents the percent of states in the country with dairy farms X years after 2000. What does P of 8 equals 85 represent? Fill in the blanks with the correct number. So in the year blank, blank percent of states have dairy farms. So X is the years after 2000. So 8 years after 2000 would be the year 2008. So in the year 2008, what percent of states have dairy farms? Well, that would be the 85. So in 2008, 85% of the states have dairy farms. That's it. Not too bad. All right, 16, systems of equations. Because I know y'all love them so much. Okay, so this is one I would use substitution for because it's easily set up for substitution. Do not forget that this is the calculator portion. On the DRC, on your interim, you have a link to a graphing calculator. Okay, that link is Desmos. So I don't want to. Okay, so look, I don't want to say you can just use Desmos, because they may disable it for a question or two. I don't know. I wouldn't think so. But what you could do is if you have Desmos, you could type in those two equations and find where they intersect. Now, they may ask for you to show your work on DRC. You may have to actually type out the steps. And if that's the case, I'm going to show you how to use substitution here. Because I'm too lazy to pull up Desmos. But don't forget that you do have a link to Desmos. So if you're able to, now you won't be able to close out of the interim to get to it, but you should have a graphing calculator app built into it, and that app is Desmos. So you should be able to get in there and play with it. Yeah, so there's that. Okay. So number 16, what is the x coordinate of the solution? So we're just going to use substitution since, now if I had recorded this through a different app, I probably could pull up Desmos, but I recorded this through a different app and I'm not starting it over, so we're just, Miss Gallant doesn't have, can't do it today. We can't do Desmos today. Oh well. Alright. I'm a dork. Y'all just get over it. Okay, we're going to use substitution though. So I know that y is equal to 4x. So where this y is, I'm going to plug in 4x. So I have 3x plus 2y, but instead of y, I'm going to plug in what y equals, which is 4x. And that whole equation is equal to 44. And now I can just start simplifying. So 2 times 4x is 8x. So I have 3x plus 8x equals 44. And then I can combine like terms. 3x and 8x are 11x. And I have 11x equals 44. I can divide both sides by 11. And x is equal to 4. Okay, so 16, part A, it's not set up as part A, part B, but pretty much part A was what is the x coordinate? Boom, got it. X coordinate's 4. what is the y coordinate? Well, now that I know what x is, I can go back to either of these two equations. And it doesn't matter which one you plug it into, but don't make this difficult on yourselves. Guys, pick the one that has the least amount of steps. This one's y equals 4x. So all you have to do is multiply whatever you got for x by 4, and boom, you're done. Make it easy on yourselves. Math is the sport of lazy people. Yes, some things you just do have to do a lot of hard work and a lot of steps. But the more we learn about math, the more we're able to condense and shorten down. So math, like people who are good at math find ways to do it with less steps, okay? Don't make it more complicated. Don't feel like you're a better mathematician if you can plug it into the big one. The real math people would plug it into the little one. Actually, the real math people would plug it into both and double check, but you know, just saying. You should not get this question wrong, because you can always plug 4 and 16 back into these equations, and if it's true, then you, if it's a true statement, then you know it's right. Now again, it is timed, so if you don't have time to check it, okay. But if you have time, if you still have 10 minutes remaining and you don't check your work, I have no respect. That's all I'm going to say. That's not true. But I would, if you have 10 minutes remaining, please check your work. Just double check it. It doesn't take that long. Flag this question. Just be like, look, I need to go and plug them back in and make sure that they're right. Okay, I'm off my soapbox. Number 17. Okay, Pepe, I like that. Pepe earns $10 an hour working at a grocery store and $14 an hour delivering pizza. He wants to make at least $500 a week, but he can't work more than 40 hours. He doesn't know about taxes. Poor little Pepe. Actually, I want his job. That's just as much money. That awkward moment when your math teacher discovers that if you work at a grocery, if you can earn $14 an hour delivering pizza and work 40 hours a week, that's what you ought to do. Dang it. Okay. Sorry. All right. I'm underpaid. Part A. Write a system of inequalities representing Pepe's goal and the number of hours he works. Use G for his hours at the grocery store and P for his pizza delivery hours. So we have to write a system of inequalities. We need two equations here. Or, well, two inequalities, because they're not equations because they don't have an equal sign. So we need a system here. So you want to base your system off of the two things you know. So the first thing we know is that we can't work more than 40 hours a week. So we're going to use G for his hours at the grocery store and P for his hours with pizza. So how we're going to write this is his hours at the grocery store and his hours delivering pizza cannot be more than 40 hours, or must be less than or equal to 40. Okay, easy peasy, lemon squeezy. All right, so then we have Pepe, let's see, we have his rate of pay. We know that he earns $10 an hour at the grocery store and $14 delivering pizza. So what we can do is for every hour at the grocery store, he earns $10. So that's my slope, kind of, sort of. I mean, this isn't really a slope, but that's his rate of pay per hours at the grocery store. Then for delivering pizza, he has a rate of pay of 14 per hour. So we have 10G and 14P. And we want this to be greater than or equal to 500, because we want 500 to be we want to earn at least 500 a week. I'm really rethinking career choice. No, I'm just kidding. I'm just like, dang. Actually, but if I did that, then I couldn't film these cool videos. Darn. And the world should be exposed to my sense of humor. Okay. Which combinations allow Pepe to work no more than 40 hours in a week and meet his $500 goal? Okay, so we have our system. Basically, all we have to do is plug these into our system and make sure that they, and see which one, or which ones are, make more than $500. Okay, so, I'm not sure if this is a select all or multiple choice. I believe it's one answer I don't believe it's I think it would say select all. But you have to remember that Miss Gallant retyped this. So Miss Gallant may have messed it up. You never know. I mean, it is me. So, so we're going to check them all. And that's just a good habit of getting into, because you may think one is correct till you check the second one, and then you may change your mind. So let's just get into the habit of checking them all anyway. And it's good math practice. Ha 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 ha. Okay, so the first thing I want to do is see if any of these combinations are more than 40 hours, because these have to be less than 40 hours. That would satisfy this first inequality. So 9 and 20 is 29. 15 and 20 is 35. 20 and 20 is 40. 15 and 25 is also 40. Yeah, okay, so they all satisfy the first equation. Sorry, I was about to say 45, and I'm like, wait a minute. That's not right. Okay, so they all satisfy the top equation. We're good there. So the second equation, same process. We're going to multiply the hours at the grocery store by 10, the hours at the delivering pizza by 14, and we're going to see if their total is at least 500. So again, this is a calculator question, so that's fine. So we're going to do 9 times 10 and get 90. I will say a lot of people want to plug in the whole thing in their calculator, and even when you have the graphing calculators, I don't trust it. I'm sorry. I'm going to do it one step at a time and make sure it gets right. I'd rather you do one step at a time, make sure it's right, than screw it up because of a calculator error. I can't tell you how many times so people, that's wrong. Well, that's what the calculator gave me. I'm like, well, you might have pushed one wrong button. Okay, so we have 90 plus 280, and that's a total of 370. Okay, so that is not enough money, so A is not going to work. Okay, so we'll do 15 times 10 is 150. I don't know why I did that. Actually, I can go ahead and do the times 10 ones. Okay, and then we have 20 times 14 is 280. And 280. And we have 25 times 14 is 350. Okay, and then we can add. So we have 150 plus 280 is 430. And then this is 480. And this is exactly 500. So 370, 430, 480, 500. So the only one that gives me enough money is 15 hours at the grocery store and 25 hours delivering pizza. Something that's kind of worth noticing is that the more that the pizza hours increase, the more money you earn, because you're earning more money at that job anyway. So I honestly would quit the grocery store job and just deliver pizza, but maybe you can't get 40 hours at one or the other. So I don't know, maybe he has to split it. Okay. All right, let's look at 18. And Miss Gallant promises to stop griping about pay. Yeah, no, she's teasing. The benefits are worth it. I mean, come on, dental. Okay, part A. How do you know that the system of equations below has an infinite number of solutions? Okay, so this is a really good question. Man, this would be a good one to pull up Desmos on just to play with it. So we have 2x plus 7y equals 12, and we have negative 4x minus 14y equals negative 24. So if I look at the top equation versus the bottom equation, to get from 2x to negative 4x, and to get from 7y to negative 14y, and to get from 12 to negative 24, I just have to multiply by negative 2. So if I multiply the top equation times negative 2, I get the exact same thing that's on the bottom equation, which is fine. We're able to do that. It's the same thing because you're multiplying the left side and the right side by negative 2. So it's balanced. So basically what that means is I have two of the same equation. This one's just scaled. Ouch. What I did. Ran my hand into my drawer. That was just me being stupid. Okay. What does I say? Okay, so these are two of the same equation. So the top and bottom equations are the same. Okay, and let's think of one other thing. Let's talk about slope and y-intercept. So how do you find the slope of something in standard form? Well, slope, if you remember, is negative a over b. Yeah, I had to double check that, negative a over b. So if I look, the slope of equation 1 is negative 7 over 2. The slope of line 2 is positive 14 over negative 4. And if I look, these two are the same, since they're equivalent fractions. Negative 7 halves and negative 14 fourths, doesn't matter if the negative's on top or bottom. It's the same, yeah, but these are the same, these are the exact same slope. One of them is just a scaled fraction. You could reduce this fraction to negative 7 halves. So they have the same slope. So if they have the same slope, they either are infinite or no solution. There's not a one solution there. So if it's no solution, they would have different y-intercepts. If it's the same solution, if it's infinite solutions, they have different y-intercepts. And so that's where this c value comes in. The y-intercept is going to be your c value over your b value. So for one line, we have 12 over 7. For the second line, we have negative 24 over negative 14, which will reduce to 12 over 7. So they have the same slope and the same y-intercept. So if the same slope, same y-intercept, is two of the same line. Okay, so part B, when does a system of linear equations have no solution? So in order for them to have no solution, then you would have to have two equations with the same slope but different y-intercepts. So for example, if I had these two equations just as they are, but I changed one of these numbers, so let's say I changed the 12 to a 10, then no matter, so if I change that 12 to a 10, then it would have no solution because they would have the same slopes but different y-intercepts. If these two numbers were different and I changed either the number in front of y or the number in front of x, then that would have one solution because the slopes would be different, and then the y-intercept would really and truly, if you changed either of these numbers and not this one, you would have different slopes. You would have at least one solution. So if these are the same, you can't have, if you have the same y-intercept, you can't have no solution because you will at least have the same y-intercept. So yeah. Okay, so there's a couple of different things that you can do with that, but I would just try to remember how to find your slope and y-intercept even if it's in standard form. Okay. So 19, Charlie's dog pen is rectangular. Its length is 3 feet longer than its width. The perimeter of the pen is 38 feet. So part A, what are two equations that can be used to show the dimensions of the dog pen? Define your variables. And then what are the measurements of the dog pen? So we have to write the equations and then we have to solve. So we know our length is 3 feet longer than the width. So to write that, I would take my width and add 3. Okay? And actually, we screwed something up. We forgot to define our variable. So what's L? L is our length. W is our width. Okay. The other thing we know is the perimeter. So I have a lot of people who forget what perimeter is. And the word, and maybe this is dumb, the word rim is in perimeter. It's the rim around the shape, or it's the distance around your shape. So maybe that's dumb, but it is the rim of it. It's the outer edge. Okay, so I know the total perimeter is 38 feet. So that would mean I would add my length plus my width plus my width to get my perimeter. So we have our length plus our length, so that's 2 of our lengths, plus 2 of our widths, and that should equal 38. So these are not the only 2 equations you could have written. I actually wrote it with just 1 equation at first, and I'm like, oh, it does ask for 2, so I had to split it up. So if we think about this, our shape, we have the length is W plus 3, and then the width is just W. So you could just add all these together. So how many W's do I have? I have 4 W's. And then I also have 3 and 3 is 6. So our perimeter is 38. So this is actually what I did. But it's fine. I mean, if it asks for 2 equations, you can do it in 2 equations. I think there's a few different ways you could go with it. Okay, so part B, what are the measurements? So let's kind of use the system just because that might be easier for some people. So we're going to plug in W plus 3 for L. So it's going to be 2 times W plus 3 plus 2W equals 38. Okay, first thing I want to do is distribute my 2. And that's going to give me 2W plus 6 plus 2W equals 38. 2W and 2W is 4W plus 6 equals 38. Going to subtract 6. 4W is equal to 32. And divide both sides by 4. And W equals 32 divided by 4 is 8. So my width is 8. Now it does ask for the measurements of the whole pen. So we have a width of 8. My length is 3 more than the width. So my length should be 11. So, and now it is measurement, so we do want to talk about feet. So my width is 8 feet. Length is 11 feet. And just to check, we want the perimeter to be 38. So 11 and 11 for my 2 lengths is 22. Plus 8 is 30. Plus my 8 for my other width is 38. So that works. That should be a true statement. So, boom. Okay. I believe this is the end of the practice test. Yes, it is. I had to double check. So that is the end of the practice test. So I'm looking at this. I'm clocking it in at 33 minutes, which is not too terrible considering my track record. And I got off topic a few times. So you will have approximately 40 minutes on the calculator session tomorrow. And it took us 33 minutes with me getting on tangents. So you should have plenty of time when you get to the calculator section, is all I'm saying. I hope this video was helpful for you. If you have any questions, feel free to email me or Miss Means. Watch this video as many times as you need to help yourself. I hope you guys have a great evening. Good luck. Study hard.